Hello and welcome everyone. Very happy that we're all together again. In this tutorial we will start discussing another outdoor lighting system, which is the playground lighting system. So fasten your belt and let's get started. The aim of this tutorial is to learn how to design the playground lighting system by discussing the different steps of the playground lighting system design. So let's go ahead. First of all, we need to know what are the different parameters we design the playground system according to. Here the first parameter is the playground area. As we know, when the area increases, the required value of illumination must increase to distribute the lighting on a larger area. And the inverse is right, as when the playground area decreases, at that case we need a smaller value of illumination or we need less lumens. So we know firstly the playground length and width to get the total area of the playground. Also the second parameter we have or we need is the playground type. This is because each type of playground needs a specific value of lux or illumination according to its nature or according to its type. For example, if we are making a design for a football playground, it needs a value of lux that is different from the tennis playground, and those two types of playgrounds will have a different design from the basketball playground. So what we wanted to say is that according to the playground type, we specify the required value of illumination, and also we specify the different designs of distributing the lighting poles according to the type of the playground itself. Very good. Now the third parameter we need for designing the playground lighting is the required value of lux or the required value of illumination. So we get the required value of lux from the code which we are working according to. And also the fourth factor we have is the luminaire itself or the type of the luminaire itself. This is because we use some specific types of luminaires in the playground lighting, and the first type of those luminaires is the metal halide luminaire, and this is because the metal halide gives a clear illumination as it has a higher color rendering index as we know before, and we need this clear illumination or this higher color rendering index in the playground lighting because the vision of the playground must be clear, as the players should have a clear vision while they are playing. And also the second type of luminaires we have is the LED luminaire, and the LED luminaire is used due to its larger output lumens, and also its power input is low, so it's a saving power luminaire as we learned it before. Alright, now the fifth factor we have is the position of distributing the lighting poles, as the position of the lighting poles depends on the type of the playground itself. So for the football playground, the lighting poles are installed on the four corners of the playground, hence the luminaires are installed on the four corners at the lighting poles which they are installed on them. So that's for the football playground at which the poles are installed at the corners. But on the other hand, for the other types of playgrounds, the lighting poles are installed on the two sides of the playground at a percentage of 1:1. So at a percentage of 1, the first luminaire is installed on the two sides, and at a percentage of 2, the second luminaire is installed at the two sides also. And also this pole has a percentage of 1 from it to the last corner or to the last side. And this means that if the total length of the playground is 40 meters, for example, there will be two poles on each side of the playground, and they will be installed on a distance of 10 meters from each corner, while the distance between those two poles will be 20 meters. While the distance between the first pole and the second pole on the same side will be 20 meters, and the distance between the second pole and the other side or the right side will be 10 meters, and this is to have a total length finally of 40 meters as we said. Very good. Now the final parameter we have is the pole height, so we need to know how to calculate the height of the lighting pole. Here we say that the lighting pole height must be larger than 2/3 times the playground width, so we detect the pole height according to the width of the playground. As the pole height should be larger than 2/3 of the playground width, and this is for the luminaire which is hanged on the lighting pole to cover all the area of the playground. Alright, so that's for the different parameters required for the playground lighting. Hope that's clear right now. Thank you for watching and see you next tutorial. Hello and welcome everyone. We're happy that we are all together again. In this tutorial, we will start practically design the lighting system for the playground using the Dialux software. So let's start. First of all, after opening the Dialux software, we will select a new exterior project as we are working now on an exterior project as the playground is an exterior one, not an interior one. So we press on new exterior project. And now suppose we need to make the lighting design for a tennis playground. So our design now will be for a tennis playground. And the first thing we need to do is to get the area of this tennis playground. So to get the correct dimension of the tennis playground, we can easily access a layout for an actual tennis playground. And for that purpose, I have provided for you this CAD layout, which has the design of a tennis playground, so we can access it or we can open it. Now this is the CAD layout we have, and if we zoom in a little bit, you can see those are 3 tennis playgrounds, and we can focus on one of them to work on. So this is the tennis playground. It has this total area with those borders, and it has an inner area for the actual playground area. So we have 2 areas, the inner area or the smaller area for the playground, and the other area for the borders or for the total borders of the playground. And for this purpose, we can measure the length and the width of the outer area of the playground, and we can do this easily by pressing on linear, and we start measuring from that point till that point, and that's it. Here the length of the tennis playground is 33.8 meter, and for its width we press also on linear, and we start from that point till that point, and we go there. Here its width is 23.2 meters. So we will go back to the Dialux software to insert those dimensions to get the outer area or the total area for the tennis playground. Here at the Dialux, we press a right click and then edit ground element. And here for the length, it will be 33.8 meter. And for the width, it will be 23.2 meters. And that's it. You can see this is the playground we have. We can press on OK. So this is the total area of the playground. But you can note that we are working now on the outer dimensions of the playground, not the playing zone dimensions, as the playing zone dimensions will have a smaller dimension dimensions than the outer zone area. So we need now to enter the inner playground area. And for that purpose, we go to the Objects tab. Here we access the Objects tab, and then we can drag this tab a little bit, and we will select the Sports Facilities. And at the Sports Facilities, we select a tennis playground. So we press a double click on tennis, and that's it. You can see this is the inner area we need, or this is the playing zone area. But we need to edit its dimensions also. So for the playing zone area, we need to enter its length and width. And for that purpose, we jump back to the CAD layout, and we will select the length and the width for the inner area by pressing on linear and start from that point till that point. And here the length is 3.7 meter, and the same thing for the width from that point till that point. So its width is 15.3 meters. Here we go back to the Dialux to enter those dimensions. Now at the Dialux, we select the inner playground, and for its length, it will be 30.7 meter, and for its width, it's about 15 meters. That's good. You can see this is the outer playground and this is the inner playground. Now what we will do is to align the 2 playgrounds at the same center. So we need the 2 playgrounds to have the same center or to align them together. So we select the outer borders, and we can drag its center here to be the same center of the inner playground. And that's it. You can see the two playgrounds are aligned together. Now we can drag this tab to the left a little bit, and we can zoom in a little bit to focus on our playground which we are working on. After that, what we need to do is to specify the positions of the lighting poles. And if you remember in the previous tutorial, we said that for the playgrounds like the tennis or the basketball, the poles are installed on a percentage of 1 to 1. So we need to specify now the lines at which the poles will be inserted. And the important note here is that the lighting poles are inserted practically on a distance of 2 meters far from the borders of the outer area. So if this is the border of the outer area, the lighting poles will be installed on a line that has an offset of 2 meters from this outer border to be at that line, for example, apart from the outer line with 2 meters. And to do so, or to draw the line that the poles will be inserted on, we will press on this draw reference line, and we will start inserting the difference line from that point till that point. And our new line now will have an offset which we enter here at that tab. So we enter the offset to be minus 2 meters and we press on OK. That's good. Here this is the new line that the poles will be inserted on, and it's far from the border line with minus 2 meter, and here this minus because the new line is down from the main line, not above it. And we will do the same thing by drawing a reference line down here from that border. So we go to the draw reference line and we start from that point till that point, and at that case we will make the offset to be a positive 2 meters, not negative 2 meters. This is because the new line will be above the down line. After that, we need to insert another 2 lines that intersects with those lines. So if this is a horizontal line, we need a vertical line that intersects with this line to have the percentage we need of 1 to 1. So the total parts we have now is 1 plus 2 plus 1, which is 4 parts. And this means that the total length of the playground will have 4 parts. Hence, we will divide the total length over 4 to get the single length of the single part. So the total length now is 33.8 meter, and we need to divide it over 4. So we will open the calculator, and here we divide 33.8 over 4. So it gives us a length of 8.45 meter. And what we will do now is to draw a reference line starting from that point, and it will have an offset of 8.45 meter. So we draw reference line from that point till that point, and now the parallel spaced apart or the offset will be 8.45 meter, and press enter. That's good. You can see we have inserted our line, and the 2 lighting poles will be inserted at that point and at that point. Now we will do the same thing. We draw a reference line from that point till that point. And now the parallel space apart will be minus 8.45 meter. This is because we need the new line to be on the right side from the reference line. So we press enter, and that's it. Here those are the intersection point, this point and this point, and the lighting poles will be installed on them. So this is the percentage of 1, this is the percentage of 2, and this is the percentage of 1. More than great. So that's about this tutorial at which we handled our playground we need, and on the next tutorial we will continue making our tennis playground lighting system design to finish it. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. We're happy that we're all together again. In this tutorial we will continue designing the playground lighting system for the tennis playground which we have created on the previous tutorial. So let's start. First of all, we need to insert the luminaires which we will use to illuminate this tennis playground. So as we will open the Dialux catalog. Here we press on luminaire selection, then Dialux catalog, and then Philips lighting. Now as we are working on an outdoor project, so we ensure that we are selecting here the outdoor selection, not the indoor selection. After that, we can search for the luminaire using the family name at that time. So we select the family name, not the family code or not the luminaire category. After that, for the playground luminaires, we have two important families which we can choose from. The first one is called Arena Vision and the second one is called the Power Vision. So those are two popular families which we can select from. And here we can type Arena Vision. That's it. As you see, for the Arena Vision category, we have those three luminaires. The first one is 1000 watts, so its input power is 1000 watt, and it works on a power or on a voltage of 230 volts. And the second one also is 1000 watt, and it works on the same voltage, 2000, and it works on the same voltage level, 230 volts. And the third one has an input power of 2000 watts, and it works on a voltage level up to 400 volts. So let's select this first one, for example, and we can select this distributor, and that's it. You can see this is the physical shape of this luminaire, and this Arena Vision luminaire is used for the playground lighting especially, and it has an input power, and it has a total output flux or a total output illumination of 100,000 lumens. So it produces a larger value of flux, and for its light output ratio it's 0.79, and for its input power it consumes 1078 watt. And you can see this is its polar curve, it's a symmetrical one, and it goes straight with a higher length but with a lower width, so it doesn't spread the light on a larger width, but it spread the light directly on a larger length, as you see. Very good, so that's an example for the Arena Vision luminaire used for the playground lighting. Now we can change the selection to the second one, which is the Power Vision. So we type here Power Vision. This one, for example, this is the second one used for the playground lighting. Here we have those options. The first one has an input power of 1000 watts, and the second one is the same. We have also 2000 watts, and we have the third one. So let's select this first one, which works on a voltage level of 220 volts. So we can select it, and we can select this distributor. And that's it. You can see this is the physical shape of the Power Vision lighting luminaire, and this is its total flux of 85,000 lumens, and its light output ratio is lowered a little bit to P0.73, and for its input power it's also 1041 watts. So those are its specifications or its datasheet, and you can see this is its polar curve. It's very obvious that it has a symmetrical polar curve, as the distribution of the light on the right is almost the same as the distribution of the light on the left, but it has a wider range of the light distribution, as it has a wider width here for the light distribution on the right on the left, while for the Arena Vision category it was having a smaller width of the light distribution. And for that reason we can select this Power Vision one, or it's more suitable for our design. Now we can select this luminaire by pressing on Add. That's it. Here we have added it to our project. After that we will close the Philips catalog. Now at that point we need to insert our luminaire, so we press a right click. Now at that point we need to insert our luminaire, so we press a right click and then insert luminaire. And then we will select the flood arrangement, and then we will insert the luminaire according to the flood arrangement. This is because we are working on a playground design, so for the playground the suitable arrangement method for the luminaires is the flood arrangement. Here we select floodlight arrangement, and as you see this is the luminaire which we will use, which we have just picked from the Philips catalog. Here those are its datasheet. Here this is its datasheet or its specifications. Now for the correction factor we will make it to P0.7. This is because we are working on an outdoor project, not an indoor one. So we suppose the worst condition to have the larger losses. And at that point, we need to specify the number of luminaires which will be installed on each pool. And then we go to the second tab, which is the arrangement tab. And here we need to specify the number of luminaires that will be installed on each pool, as the power vision luminaire will be installed on the lighting pool. But we select the number of luminaires which will be installed on each pool. And for that purpose, we will find here we have this number, so we can select the number of luminaires initially to be 1 luminaire per each pool, as this is the number of luminaire per each pool. So we will set it to be only 1 luminaire, and this is by default. And after that, we will check our results. So if we find that the required value of lux is smaller than the achieved value, we can increase the number of luminaires per pool. Hence, for the number of luminaires, we increase it if we found that we are getting less value of lux in the results. Very good. Also, you can see we have those two options. The first one is mirror horizontally and the second one is mirror vertically. So if we check those two options, this means that the changes which we made on one luminaire or one pool will be performed on all the pools we have. So once we change the design of one pool, all the lighting pools will have the same design, as we are reflecting the changes to all the pools by this mirror option. So we will select this mirror horizontally and this mirror vertically. Here we check them, and now you can see, and then we press on insert. That's good. You can see this is one luminaire hanging on one pool, and this is the second one, this is the third one, and this is the fourth one. But as we said before, we need the luminaires to be installed on a percentage of 1 to 1. So we will pick this luminaire, for example, and we will install it at that point. And that's it. You can see all of the luminaires we have, or the 4 luminaires we have, has been changed, or their positions have been changed. This is because we are making the mirror horizontally or the mirror vertically. So once we change the position of one of them, all of the luminaires has been changed, or the positions of all of the luminaires have been changed. Also, we can change the angle that this luminaire is hanging with. So once we select the luminaire, here we can change its angle. This is the forward angle that the luminaire will be installed on. So we can make it to be that one, for example. And that's it. Once we change one angle for one luminaire, the other angles of the other luminaires has been changed. Very good. Now the next thing we need to do is to achieve the required value of lux for this playground. And to do so, we need firstly to know what is the required value of lux of this tennis playground. And for that purpose, I have provided for you the code that we will pick the tennis playground value of lux which we need. So we can open this file. And in this file, you can see we have this PDF for the lux required for the tennis playground. So we can open it, and that's it. Here, this table have the standard value for the required lux, and that's it. Here you can see this file have this table which contains the standard value of the required lux for the tennis playground. So we can suppose that we are working on a social playground and we need the average maintained value of lux. So this is the value which we need, which is 250 lux. But if we are working on a competition playground, we will select this value, which is 350 lux. And if we are working on an international playground, we will select this value of 1000 lux. But for us, we will suppose that we are working on a social playground, so our required value of lux is 250 lux. Very good. Now we can jump back to the Dialux. And then we will start our calculation to calculate the value that we have got of the lux. And then we press on OK. Here it's loading. That's it. You can see this is our playground. And after that, to see the results, we press on the Output tab. And then we access our project. And after that, we open the exterior scene 1. And then we go down a little bit. And then we access the exterior surfaces. After that, we press on the tennis 1 calculation, and here we have the summary. We press on it, here we select it, and then we press on it to double click. And that's it. Here, this is our playground, and if we go down a little bit, you can see we have the average value of the lux to be 222, so it's lower than the required value, as the required value is 250 lux, and for that we need to reach the required value of the average lux. And for that purpose we will go back to our design, so we press on this tab, and then we press a right, and then we go to our project, and here, and then we press a right click, and press on floor XY plan, and at that point what we can do is to change the angle at which our luminaires are installed with. So we select our luminaire, and then we can change the angle to P, that one for example, and then we press on yes, and here we can change our angle. So we select our luminaire and we change the angle to P, that one for example, and then we start the calculations again and press OK. And then we go to the output again, and then the exterior surfaces, and here we press a double click on the summary, and that's it. Here if we go down, we will find that the average value of lux has been increased to P 257 lux, so this is the required value, or this is a very near value to the required value, so we have achieved our required value of the lux for this tennis playground. And here this is our 3D view for the playground. We can rotate it to see our luminaires. So this is the playground, and those are the 4 luminaires installed on the 4 pools. We have this luminaire, here this one, and this second one, and the third one, and this fourth one. Very good. So that's about our design for the tennis playground. Hope that's clear right now. Thank you for watching, and see you next tutorials. Hello and welcome everyone. Very happy that we're all together again. In this tutorial we will talk about a very important topic in the lighting system, which is the emergency lighting. So we need to know firstly what is the emergency lighting system and how can we design it. So we can project our illustration on this meeting room, which we have talked about before, or which we have designed its lighting system before. Now suppose we have this meeting room. Here at the normal case, the luminaires will be on and the lighting system will work smoothly with no problem. But suppose a case at which the power supply which is feeding this lighting system is getting off due to any problem in the electrical utility or due to any problem in the power supply itself. Now we are at a trip condition, or we are at a fault condition at which the power source which is feeding this lighting system is off. And as a result, all the luminaires will be off and there will be a failure in the lighting system. So this meeting room will be dark. And from here we come up with the idea of the emergency lighting, which is to select some luminaires of those luminaires which will be fed from 2 power sources at the same time. Hence, some of those luminaires will be used as an emergency lighting luminaires, which means that we will feed them from 2 power sources. The normal power source using which the luminaires will be energized at the normal condition, and the emergency lighting source using which the same luminaires will be energized also, but at the emergency condition or the trip condition of the main power source. And we need to do so not to make the room totally dark at the trip condition of the main power source, but there will be a backup source which will feed some of those luminaires to be on in case of the main power source is getting off. Very good. Now the important question is that how can we select the emergency luminaires from all of those luminaires we have in that room? Or in other words, what is the idea at which we can select the emergency luminaires according to? Here we say that we select the emergency luminaires to be 25% of the total number of luminaires we have. So 25% of those luminaires will be used as emergency luminaires. And here in our case, if we count those number of luminaires, we will find here we have 1, 2, 3, 4, 5 times 3. So those are 15 luminaires, and we have here 2 other luminaires. So the total number of luminaires for this room is 17 luminaires. And if we get the 25% of the 17 lumineers, they will be approximately about 4 lumineers. So 4 lumineers of those 17 lumineers will be fed with 2 sources, as they will be used as emergency lumineers, as in case of the main power sources getting off, those 4 lumineers will still working, as we have another power source that is feeding those 4 lumineers. And we can select those 4 lumineers to be this one, for example, and this one, and we can select the third one, and we can select this fourth one, for example. So we select the emergency lumineers from different parts of the area, not from only one part. And this is to ensure that all of the zones of the room will be on at the emergency condition, not only one zone and the other zone will be off. And this is to distribute the lux in the different parts of the room at the emergency condition. Very good. Now the important question is that how can we design the emergency lighting system in the Dialux software? So how can we make the Dialux recognize that those 4 lumineers which we have selected will be the emergency lumineers? Here to do so, we need to split the lumineers firstly, not to handle them as a group of lumineers, as now they are one group. If we select any one of them, all of the lumineers will be selected, so we need to split them. And for that we press a right click and then split. And then press yes. And that's it. Here if we select any one of them, this lumineer only will be selected if we select this one or this one, or this one, for example. Very good. Now to select the emergency lumineer, we will press on Shift on the keyboard and still pressing Shift and select the first one and still pressing Shift and select the second one and select the third one and also select the fourth lumineer. So those are the 4 lumineers which we have selected. And now we will press a right click. And then we will press on Add to Control Group and then New Control Group. So we have added those 4 lumineers to a control group to add them to the same group, which is the emergency lighting system. And this is the group name. We can rename it to P Emergency Lumineers. So by that way we have added the emergency lumineers to one group that the program will recognize as one lighting system, which is different from the main lighting system or the normal lighting system, which has all of the lumineers. Very good. After that we go up a little bit and here we select this control group, we press a right click and then we press on Add Light Scene and then we select New Light Scene. That's it. This is the light scene at which the lighting system or the emergency lighting system which will be added to. So we can rename it to P also emergency lighting. And that's it. Now if we need to express the results of this emergency lighting system to see what will be the performance of this emergency system or what are the results of this emergency lighting system of its output lux of those 4 lumineers which we have selected, we can go to the Output tab and then we drag this tab down and then as we are working on the meeting room, so we select the meeting room and then we press on Light Scenes and then emergency lighting. This is the lighting system which we have just created. But before that we need to start the calculation, so we press on Start Calculation and this is for the emergency system for the meeting room. So this is the emergency lighting which we have just created. We select its lumineers and then we press on OK. And that's it. You can see this is the room which has the 4 emergency lighting lumineers. But we will go down a little bit and here we have the emergency lighting at which we have the summary, so we press a double click on the summary and that's it. You can see those are the 4 lumineers which we have selected for the emergency lighting, this one and this one and this third one and this fourth one. And for the average lux of them it's 64 lux and for U-Note it's 0.41. But here at the emergency condition, we don't care about the U-Note factor because there will be no uniform distribution of the lux anyway, as many of the lumineers in the room is off. So there will be some areas which has no lighting system, like this area or this area. And by that way, we don't care about U-node, but we care about the average lux, or we care about the number of luminaires to be 25% of the total luminaires. Also, we can see our room in the 3D model, so we can rotate it a little bit. Here, that's it. Those are the 4 luminaires which we have selected to be emergency luminaires. Very good. But the important note here is that not all the cases, or at not all the cases, the percentage of the emergency luminaires will be the same percentage. As we said before, we use 25% of the luminaires to be energized or to be on at the emergency condition, but this 25% is not a constant percentage, as this percentage depends on the nature of the room which we are working on. As if the room which we are working on its emergency design is not a critical one, we will use this 25%. But on the other hand, if the room we are working on is a critical one, or we use it in a very important purpose, like the operating room for example, at that case we will use 100% of the total luminaires to be emergency luminaires or to be on at the emergency condition. This is because the operating room is a critical room that its electrical power must be turned on at all the cases, so it must have a supplying system at all cases. And for that purpose we can go to our project and go down a little bit, and here we select our operating room and press a right click and then see its floor plan. So that's our operating room which we have created its lighting system before. Here, if we need to make an emergency lighting system for it, we will select all of the luminaires to be emergency luminaires. So we can try now making the emergency lighting system for this operating room. Here we select this arrow, and then we select one luminaire. So all of those luminaires are selected, but here we have those 2 luminaires also. So we press on Shift and select this 5th luminaire, and then select this 6th luminaire by pressing on Shift also, and after that we press a right click and then add to control group and then new control group, and now we can rename this control group to P, the operating room emergency, and that's it. Here we press on enter. As you see, we have a new control group which is this operating room emergency lighting. We press a right click on it and then add to light scene and this new light scene, and then press on yes. And then for this light scene we have the operating room emergency system, so we select it and then we start the calculations to calculate the lighting system for the operating room. Here we select it and press on OK, and that's it. You can see this is the 3D view for the emergency room lighting system. Here all of the luminaires are on. This is, we need 100% of the luminaires to be on for the emergency lighting system for the operating room. And to see its single sheet output, we go to the output and then the light scenes, and then we select the operating room. After that, for the operating room we need the light scenes. Here light scene 1, and we select its summary, and that's it. You can see all of the luminaires are on, and the E average is the total lux of 436, and for the U node it's 0.73. That's it. So by that way we have designed the emergency lighting system for the operating room, which includes all the luminaires in its lighting system. So that's about the emergency lighting system. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. We're happy that we're all together again. In this tutorial we will discuss some important details related to the interior lighting system design. So we need to cover many aspects related to the different design conditions for you to face the different cases during your lighting system design. So let's start. Suppose now we need to make a wall-mounted lighting system design. So you may need to insert some luminaires on the walls, not only on the ceiling, as all the designs we made before was related to the ceiling-mounted luminaires. But we need now to know how can we make a wall-mounted lighting system design. And for that purpose, we can't work on another room, so we can select this room, for example. Here we can focus on this room. As you see, it seems that to be a patient room, which has some beds, and the patients are sleeping on those beds. And as usual, we press on Insert New Room, and then we go up. Here we go to our room, and we press a right click, and then Draw Rectangle. This is because we have a uniform room which has only 4 walls, so we press on Draw Rectangle, and we start from that point, for example, until that point. That's it. So that's for the room length and its width. And for the room height, we will make it to be 3.25 meter. And this is by supposing that we have a suspended ceiling on a height of 0.75 meter from the main concrete ceiling, as the total height of the room is 4 meters. After that, we press on OK. And now we need to add the wall-mounted luminaires. So we open the luminaire selection, then Dialux catalog, then Philips lighting. After that, we ensure that we are using the indoor luminaires. And then we drag this tab a little bit. And here we can search according to the luminaire category. And for the luminaire category, we can drag this tab down, as we need now a wall-mounted luminaire, so we will select the wall-mounted. And here for the wall-mounted, we have many types of the luminaires. We can select this one, for example, and we can select this housing, and that's it. You can see this is a wall-mounted luminaire. It seems one to be an opal one, as it has an opal cover. And this is its polar curve. It has a wide polar curve, and it's a symmetrical one. And this is its total output flux of 1600 lumens, and its input power is 24 watts. Now we will press on Add, and then we close this tab. After that, we press a right click, and then Insert Luminaire. And at that point, we will use this selection, which is the line arrangement. So we will not use a field arrangement, but we use the line arrangement, as the luminaire which will be inserted on one line on the wall. So we press on line arrangement, and then for the correction factor we made it to be 0.8. Very good. Now we go to the second tab, which is the mounting. So it asks us for the quantity of luminaires we need. So we may need here only 3 luminaires, and that's it. Now we press on Insert. As you can see, those are the 3 luminaires which we have. They are inserted on one line, but we need them to be on that wall, so we can drag this line down, and that's it. You can see those luminaires are inserted on that wall. And here at that point, we need to specify the height that those luminaires will be hanged on at the wall. And for that, we select any of those luminaires, and we press now on the mounting height. And here we change the selection for the mounting type to be according to the user defined. So by that way, we will specify exactly the height of those luminaires. So let's make the mounting height to be 2 meters, for example. So by that way, we suppose that those luminaires, or those 3 luminaires, will be hanged on a height of 2 meters from the ground of the room. And after that, to see the output results of this lighting system, we press on Start Calculation, and we go down a little bit. And here we include the luminaires of this room. So we press on that selection, and then press OK. Very good. Here you can see this is the 3D design for that room. Here those are the 3 luminaires hanged on that wall on a height of 2 meters from the ground. So this is the physical shape of those luminaires. Now we can press on the single sheet output to see the results. Here for that new room, press OK, and then view full width. And that's it. Those are the luminaires we have. We have an average lux of 79 watt. We have an average lux of 79 lux, and unit is 0.65. But what we need to say here is that those wall-mounted luminaires are not used frequently to get a specific value of lux, but we use them for the decorative shape, or we use them frequently for the decorative design, as the aim of the wall-mounted luminaires in many cases is not to get an accurate value of lux or an accurate illumination, but it's used for a good outlook of the room or a good decorative shape of the room. Alright, now we close that tab and we go again to our room. Now the next note we have is related to the suspension height of the recessed luminaires. As we said before, if we have a suspended ceiling at which we installed some recessed luminaire, we put the luminaires to be on a height of the suspended ceiling, not the total height of the concrete ceiling, and this is because the luminaires are installed on the suspended ceiling and they are not installed on the concrete ceiling. And for that purpose, we make the ceiling height of the room to be 3.25 meter, which is the suspended ceiling height, not the total height of 4 meters, if you remember, as the 4 meters is the total height from the ground, as the 4 meters is the total height from the floor until the concrete ceiling. But suppose now we need to enter the room height to be the total height of the concrete ceiling, which is 4 meters. But at the same time, we need to use a suspended ceiling at a height of 3.24 meter, as we need to add the luminaires on that height of the suspended ceiling. So how can we do that? Here we can try doing so we press on this arrow tab, and then we press a right click, and then edit room geometry. Here for the height we will set it to be 4 meters, not 3.25. And then we press on OK, and then press yes. And now we will change the suspended ceiling height when we insert the luminaires. So we press a right click, and then insert luminaire, and at that case we need a field arrangement, as we need some luminaires on the ceiling. And then we can select any luminaire which we have selected before, or from the luminaires which we have selected before. So let's select this one, for example. And we change the correction factor to be as use 0.8. And after that we go to the mounting tab. So at the mounting tab we will not use the recessed mounting, but we will use it as user defined. Here at this mounting height we will not make it to be 4 meters, but we will make it to be the height of the suspended ceiling, which is 3.25 meters. So although here we have the total height of the ceiling to be 4 meters, but we have the mounting height to be only 3.25 meters, which is the suspended ceiling height. Now we can change the number of luminaires to be, for example, 4 rows and 3 luminaires per row. Here 3, and then we press on insert. So by that way, although we have, now we can start our calculations. And then choose room 11 and press OK, and that's it. Here you can see those are our luminaires. We can rotate our room, so it's very obvious that the luminaires are not installed on the total height of the room, which is 4 meters, but they are installed on about 0.75 meter from the main concrete ceiling, or from about 3.25 meter from the floor. Very good. Now we can go back to our project. We press on floor plan, and here the final note we have is that after finishing our project, suppose we need to export the results of any summary of any lighting system we have. Here to do so we press on file and then export, and then save output as PDF. And here it asks us for the number of pages we need, so we will select all the pages of all of the rooms from 1 till 26, and then press OK. And now it's generating the files, and then it asks us for the location at which we need to save this project. So we can save it in the downloads, and then we can rename it to P output results, and then press save. And that's it. Here by that way we have saved our output results, so we can open it, and we have another way for opening it, which is to press on file and then print preview and then press OK. After that we press on view full width, and here this is our project 1, and here we go down And then we go to the next page. This is the table of content for our project. The luminaires part list, which have the luminaires which we have used, and the rooms we have. And we can go to the next page. Here, those are the data sheets for the luminaires which we have used, and for the number of them. Here for that we use 3 pieces, and for that we use 28 pieces. And those are the luminaires. We can go to the next page. Here we have this luminaire also, which we have used in this lecture, and this one. And if we go there, we will find that all of those are the luminaires with their data sheet. And here we have the lighting design also. So the lighting design for the waiting room, and also for the corridor, and for the meeting room, and so on. So all of those are the output summaries for the different rooms which we have created in our project. Very good. So that's about this tutorial. Hope that's clear right now. Thank you for watching, and see you next tutorials. Hello and welcome everyone. Very happy that we are all together again. In this tutorial we will continue designing the lighting system using the Dialux software. So let's start. When you install the Dialux software, you may notice that you have those 2 icons, this red one and this blue one. And you may notice also that in all the designs which we have created before, we use this red icon and we didn't use this blue icon anyway. So we need to know what is the difference between this blue icon and this red icon, and we need to explore the Dialux software using this blue icon. Here we say that we use this red icon if we are designing a complete project with a complete lighting system details. This is if we have many rooms on a layout and we need to design the lighting system for each of them. On the other hand, this blue icon is used if we are making a small design for just one room that we need to implement its lighting system. So we can say that the blue icon is the light one used for quick lighting system design, which contains only one area that we need to determine its lighting design. While for the red icon, it's a general one that is used for the full project that we need to make its full design. And now we can explore this blue icon by pressing a double click on it. Here this is the initial window appears for us. We press on next. And now those are the general data about our project or about our design. So we can type the project name here, and we can type here the room name. And here we can type the description about our project if we have any notes about our project. And here those are the contacts or the information about our project, the contact, the telephone, the fax, the email, the company, the address, and so on. After that we press on next. And here at that tab we need to enter the length of our room. So let's make the length, for example, to be 6 meters. And for the room width, we can make it to be 3 meters. And for the room height, we can make it to be 4 meters, for example. And then at those 3 tabs, we need to enter the reflection factors, the ceiling reflection factor, the walls, the ground. So we can set them by default. And on the down here, we type the height of the working plane and the offset of the wall zone. So we can set them also by default. And at that tab, we need to select the luminaire which we will use. So we can drag down to select any luminaire we need. Also, we can choose from the catalog and from the Dialux catalog and from the Philips lighting. Here we can select according to the luminaire category, and we can select the received mounting. And here we can select this luminaire, for example, and this distributor and this housing. And then we press on add. And after that we close. So that's a random luminaire which we have selected. And for the mounting type we can make it as user defined. And here for the mounting height we can make the mounting height to be 3.5 meter. This is supposing that we have a suspended ceiling on a height of 3.5 meter. And for the total height of the room we can make it to be 4 meters. And after that we press on next. And here we need to enter the number of luminaires over the length of the room. So we can insert 4 lumineers over the length of the room, and for the number of lumineers over the width of the room, we can set it to P2, and that's it. You can see we have here 4 lumineers and we have here 2 lumineers in each row, so the total number of lumineers is 8. And this is the distance from each luminaire to the edge of the room to P 0.75 meter, and we have the same distance from each luminaire to the other edge of the room to P also 0.75 meter. So we can change those values as we need or according to our design. Very good. After that, to see the results of our design, we press on calculate. Here it's loading. That's it. As you see, we have an average lux of 621 lux. This is a large value, but we select it randomly. We are not making an accurate design, but we are exploring our program now. And for U note, which is E minimum over E average, it's 0.76. Very good. So that's for the lighting design using the Dialux light, which is the Blue Dialux. And if we need to export the values that we have got or the results, we can press on next. And here we can print preview or save the output as PDF. So we can press on output as PDF. Then we press on save. Or we can print preview to see our project results. And also we can save our Dialux project from this tab. So anyway, you can choose any option you need, and that's about the Dialux Lite. Hope that's clear right now. Thank you for watching and see you next tutorials.